Okay, so we're going to talk about exponents and the properties that go with exponents. So there's 7 main properties that we're going to talk about, and then we're going to put them all together. So the first property, well, first off, let's define an exponent. So if I have an expression that looks like this, the x here is called my base, and the number or the power is actually my exponent. Okay, so exponents do some pretty cool things, and if you remember, the exponent tells me how many times I multiply the base. Okay, so for example, with this one, this would be x times x because it's twice because of the exponent. Okay. So let's run through these properties. The first property that we have is called the product of powers. Now the important thing to remember here is that a lot of these, and especially this one is one of them, in order for the property to be true, the bases have to be the same. Okay, so this is the same base property. But if I multiply, because product means multiply, if I take 2 terms that have the same base and I multiply them together, then what I can do is I keep the base the same, but I add those exponents. Okay, so this becomes x to the 5th. Alright, be very careful because again, the bases must be the same. So let me give you a little example. Let's say I had x to the 4th times y to the 2nd times x to the 3rd. Okay, when I look at this, I can see that I have 2 of the same bases, right? The 2 x's are the same. So what I can do to simplify this is I can say this gives me x to the 3 plus 4 is 7 times y to the 2nd power. Okay, so multiplying with the same base, I add the exponents. Now, let me give you one to try. Let's say I had x squared y to the 3rd z to the 2nd x 4 z 5. So I just want you to take a minute and try to simplify this and tell me what you get. So hopefully you have simplified this one. These are all multiplying, but I can only combine the ones that have the same base. So for the x's, 2 and 4 would give me x to the 6th. For the y's, I have just one there, it's y to the 3rd. And then the z's, I've got a z5 and a z2, and again, because I'm multiplying, I can add those bases together. Okay? Alright, let's do the next one. Remember I told you there's 7 properties, so there's the first. The second property is called power of a power. Okay? So this is exactly what it sounds like. I take something that has been raised to a power and I raise it to another power. Okay? Now when this happens, what I have to do is I multiply those exponents. So 2 times 5 would give me 10. Okay? Alright, so multiply exponents. That one's pretty straightforward. Let's move on to number 3. The next one is the power of a product. This one starts to get, you have to really think about these. Product means multiply. Okay, so I'm multiplying 2 things together, say x times y, and then I'm raising it to a power. Okay, now understand that this is not the same as this. Okay, those are two different expressions. As long as I'm multiplying in this parenthesis, okay, and you have to make sure you're multiplying in the parentheses, not adding or subtracting. So when you're multiplying in the parentheses, then we can distribute that exponent. Okay, so for instance here, I could distribute and distribute, so I would get x to the second times y to the second. Okay, now kind of piggybacking on that same property there, if I had, let's say I had 2x to the third raised to the fourth power, I'm still multiplying in here, so this exponent is still going to distribute to both of these pieces. Understand that 2 is its own piece, and I have to treat it like an independent piece. Okay, so I get 2 to the fourth, x to the, and look at this. What I have is I had the third, but now I'm raising it to the fourth. So whereas this was power of a product, all of a sudden now I also have power of a power. So I get 2 to the fourth x to the 12th because I've multiplied those exponents together. Alright, let me give you one to try. How about if I had 3x to the third raised to the second power? So you give that one a try and see what you get. When you distribute this 2, you get 3 to the second. And again, because I'm raising a power to a power here, I multiply. Okay, if you just want to change that to 9x to the 6th, you can. It's definitely not necessary, but that is completely up to you. Alright, so now let's look at the fourth property. The fourth property is the negative exponent property. Okay, so a negative exponent does not make the number negative. Don't make that mistake. If I have a negative exponent, let's say a negative 2, okay, what happens is it flips the base and it makes the exponent positive. So you might say that's a bit confusing, and I agree, so let me show you. If I put this over 1, okay, thinking like in terms of fractions, what I do is this moves down to the bottom of the fraction, okay, because that's what I mean by it flips the base. It flips the base to the bottom, so this becomes 1 over, now the 1 didn't move up, I'm just holding the spot with the 1 here, x to the second, so it becomes positive and it moves. Okay, let me show you another example. Let's say I have 2x to the third over y to the negative 1. Okay, the y is the one this time, just this piece is going to move up to the top, okay, because it's the negative piece. So I get 2x to the third y, and then there's nothing left on the bottom because that piece moved up, so it's just over 1. Let's see, let's do the next property. Let's do the next property. So no matter where that negative exponent is, make it positive and move it. If it's in the bottom, move it to the top. If it's in the top, move it to the bottom. The next one is probably the easiest. It's the zero exponent property. So the zero exponent property says that any number, anything other than 0, so anything you raise to the 0 power gives you 1. So x to the 0 is 1. 5 to the 0 is 1. Negative 13 to the 0 is 1. Anything to the 0 power gives you 1. And let me just show you on the calculator. If I raise 5 to the 0, I get 1. If I raise negative 25 to the 0, anything to the 0 power is 1. Okay? Alright, let's do number 6. The sixth one is quotient of powers. Okay? So the quotient of powers property, quotient means to divide. Okay? This is another one that it's real important to note. This is a same base property. Okay, it's got to have the same base in order for this to work. So if I am, we said this means divide. Let's say I take these same x's and I divide. Okay, they have the same base. So what I do, and if you think, when you multiply, because we had the product of powers, when I multiply I add exponents, so it makes sense that when I divide I subtract those exponents. So I get x to the 3rd power. Again, same base, so if I set up a fraction like this, I want to look at just the x's and subtract those two values. So I get x, 5 minus 4 is 1. Well, remember, you can put the 1 or you don't have to. It really doesn't matter. There's an implied one there. So let's see. Let me show you an example. Try this one. Let's say I have 2 to the 5th x to the 3rd over 2 to the 3rd x. Simplify that and tell me what you get. Alright, so the bases, same bases, because they do have the same base, so I treat them exactly the same way as I would a variable. Okay, so what I did to get these two numbers, take the base of 2, subtract the 5 from the 3, and it gives you the 2. And then subtract the 3 and the 1 to give you the 2 here, and it's simplified. Okay, let's talk about the last property. And the last property is the power of a quotient. Okay, very similar to a power of a product, only this time I am dividing. So if I'm dividing in the parentheses, and I have an exponent outside, again, I just distribute the exponent to both terms to simplify. Okay, there's already an exponent there. Of course, I would multiply them. For example, x to the 2nd over 5 to the 3rd raised to the 2nd. When it distributes, I would multiply, because then I also have a power of a power situation going on. Okay? Now, the thing with the exponents, I think what makes them the hardest is that there's not an order of operations to go, and there's not a specific order that you need to apply them. As long as you're doing valid properties each time, then you're justified in your answer. So let's do some examples together and let's see what happens. Okay, so let's do this. Let's simplify some expressions and then we'll tell what property we used when we simplify them. And you'll quickly see that there are different ways that you could go about simplifying. It just depends on which property pops out to you first. Okay. So for this one, the first thing that I see is that all the bases are the same. When all the bases are the same and I'm multiplying, of course that means that I'm going to add the exponents together. So 5, negative 8, and 6 would give me 3. Okay, and the property that we used would be the power product of powers. Okay, let's do another one. Let's make it a little bit harder. Let's do a to the negative 3 b squared over a to the 5th. Okay, so what I want to do first here, the first thing that I notice is that negative exponent. So what I'm going to do is I'm going to take that negative and I'm going to just move it down to the bottom. And that gives me, and maybe I should come here so I can write the properties down. So the b stays up top, and now I got a3 and a5 in the bottom. Okay, so that's the negative exponent property. Okay, next thing I see is that I've got 2 of the same bases in the bottom. So what I'm going to do is I'm going to combine those. 3 plus 5 would be 8, and that is product of powers. And now it's simplified. Let me give you one to try here. How about r negative 2 over s to the 3rd, and I am going to raise that to the negative 3rd power. So take a minute, if you can see it, and try to simplify that one. So several different things you can do. You could move the negative exponent first, or you can distribute through there first. I'm going to go ahead and distribute first because that's what I see first. And so I get negative 3 and negative 2 would give me positive 6. And this is actually a combination of 2 different properties because it's I'm distributing through there, so it's the power of a quotient, but it's also power of a power because I'm multiplying the 2 exponents together. So then on the bottom, I get s to the negative 9. So the only thing that I see left here is the negative exponent in the bottom, so I'm going to move that up to the top, and I get r to the 6th s to the 9th. I want to take just a second to talk to you about if the base is not a variable but is a number. All the same properties still apply. So if I have 2 over 9 to the 3rd power, it still distributes through just like it would if it was a variable. Okay, and all the same properties. You can expand that if you want. 2 to the 3rd is 8, 9 to the 3rd is 7, 29, but you can leave it just like that. It really is just fine the way it is. Let's see, if I had 6 to the 3rd times 6 to the 0 times 6 to the negative 5. Again, all the bases are exactly the same, so all I want to do is come in and add those exponents together. So 3 plus 0 plus negative 5 would be negative 2, and then, so that is my product of powers property. And then because that exponent's negative, I can move it down to the bottom, and that's negative exponent. Now, you may ask, how do I know that I'm done? You know you're done when you can't apply any other properties. Okay, when you can't apply any more of those 7 properties to any of the problems, then you're done. It's already simplified. If I look at 1 over 6 to the 2nd, I can't do anything else with that. I can't do power of a product. I can't do power of a power. I can't do negative exponent. There's nothing else I can do there, so I just leave it as it sits. I would make sure you have your properties listed handy beside you, so that you can go through and justify each property as you go. This is a lesson that looks really easy when you see it initially, but when you actually dig in and start doing the problems themselves, they can get kind of complicated. So make sure you take your time and justify the properties as you go. I'm done about that.